talk about gyroscopes. A gyroscope is basically a spinning wheel, and as long as it does not spin, I can push it and it tumbles like any other object would do up here on the space station, so nothing special about it. However, if I make it spin, even just a little bit with my fingers like that, you can see that it changes its behavior a lot. Now, it wants to maintain the orientation of its spinning axis. If I spin it faster, using a rope, you can see that even more, it does not want to change its orientation. Not only does not tumble, but it really wants to maintain the orientation of its spinning axis in space. We say in inertial space. This property is gyroscopic rigidity, and it's used a lot in space flight. For example, to maintain the attitude, the orientation in space of satellites. Now, we can use gyroscopic rigidity for a little fun demonstration of what space station does as it flies around the Earth. Let's see, I'm gonna spin up this gyroscope. And now, of course, it's spinning as it's exhibiting gyroscopic rigidity. And I have prepared a little setup here where I'm going to try and keep the gyroscope in a more or less fixed position so we can watch it in the camera without impeding it from rotating. And I'm going to start the clock, and we can see what happens. All right, it's been about 3 minutes, and you can see it looks as though the gyroscope has tilted that way. However, we know that that's not possible because the gyroscope is rigid. It maintains its orientation in space. So what happened? Well, the gyroscope has maintained its orientation in space, but the space station has tilted around it. We can try to visualize that by using Paxi as an example. Let's say this is Earth and this is Paxi flying around Earth, and Paxi always wants to look at Earth. If she didn't change her attitude in space as she flies around, after about 90 degrees she will be pointing with her feet towards Earth. But she always wants to look at Earth, so as she flies around she also tilts around her axis like that, so that by the time she's made a whole orbit around Earth, she has also done a full somersault like that. And because it takes us about 90 minutes to fly around the Earth once, that equates to about 4 degrees per minute. And in fact, as we were looking at our gyroscope, after about 3 minutes, we observed that that tilt looked about 10 to 15 degrees, so probably 12 degrees is about right.